Welcome to qnawire.
A triangle has sides of lengths 5 cm, 8 cm and x centimeters. State the range of values that x can take. In this question, we are given the side lengths of a triangle as 5 and 8 centimeters. We need to use this to determine the range of possible values for the unknown side. To answer this question, we need to recall two things. First, we can recall that the triangle inequality tells us that in any triangle, the sum of the lengths of any two of its sides must be larger than the length of the third side. So, if a triangle has lengths A, B and C, then A plus B must be greater than C. We can use the triangle inequality to construct three inequalities that must be satisfied by the lengths of this triangle. We know that the sum of any two of its side lengths must be greater than the length of the remaining side. So we have that 5 plus 8 must be greater than x, 5 plus x must be greater than 8, and 8 plus x must be greater than 5. It is worth noting that x is the length of a side in a triangle, so we know that x is positive. This means that the final inequality will be satisfied regardless of the value of x. The second property that we need to use is that if we have any three lengths, that is, positive real numbers that satisfy the triangle inequality, so the sum of any pair of these lengths is greater than the third, then there is a triangle that has these lengths as its side lengths. We can think of this as the reverse of the triangle inequality. The triangle inequality lets us check if a triangle is possible using its side lengths, and this result lets us show that there is a triangle with the lengths as its side lengths. This means that if we choose a value of x that satisfies all three of these inequalities, then that is the range of values that x can take. Of course, we have already shown that the third inequality is satisfied provided x is positive. Let's simplify each of the first two inequalities. In the first inequality, we have 5 plus 8 is 13. We can rewrite this inequality as x is less than 13. In the second inequality, we can subtract 5 from both sides of the inequality to obtain that x is greater than 3. We can rewrite this as 3 is less than x. We can then combine these two inequalities into the single compound inequality 3 is less than x is less than 13. We have shown that if x is in this range, then the three values satisfy the triangle inequality. So a triangle with these side lengths exists, and that x must be in this range for such a triangle to exist.